Good day, everybody. How are you all doing? Today, we are going to talk about the basic principles of hypothesis testing. So, here I go. So far, we have discussed or described statistical analysis as a four-step process. We formulate questions, we collect data to answer the questions. Suppose we want to find out what is the population mean age of students at an university. So, of course, we cannot reach the entire population. So, we'll work with a simple random sample and find out the sample mean age. From that, we will make an educated guess about the population mean age. So, first, we'll describe the characteristic of the sample that we have gathered, such as the sample mean, sample standard deviation. From that, as I mentioned before, we are going to draw a conclusion or make an educated guess about the population mean age. Now, that is the basis. So we work with a sample. From the sample statistic, we make an educated guess about the population parameter, which is the corresponding population characteristic. Is our educated guess right or correct? That is what we are going to learn. We are going to learn of methods that will allow us to test whether our educated guess about the population characteristic or population parameter is in the right ballpark. That is, it is within an acceptable limit. Okay, so let's move forward. We now discuss how to perform hypothesis test, which is one of the most commonly used methods for drawing conclusions. So first we will define the null and alternate hypothesis. What is null? Air pollution in a series of health problem is a serious health problem in many cities. One form of air pollution is particulate matter (PM), which refers to particles that can be trapped in the lungs. One study published in the Journal of Air and Waste Management Association reported that the mean amount of PM produced by cars and light trucks is 35 milligrams per mile of travel. A new engine is designed to reduce this level. There are two possibilities. Either the new design will reduce the level or it will not. These possibilities are called hypotheses. One hypothesis we call the null hypothesis says that the new design will not reduce the level, so the mean remains the same as population mean mu, Greek m, is equal to 35. That is the status quo. Another hypothesis, which we call the alternate hypothesis, states that the new design of the engine will reduce the level, so mu or population mean less than 35. The null hypothesis, denoted by the symbol H sub 0, states that a parameter is equal to a specific value. For example, H sub 0, null hypothesis, written like that, colon, mu is equal to 35. Okay, so it is equal to a specific value, sometimes called the status quo. Okay, the matter as it stands today. The alternate hypothesis, denoted by H sub 1, states that the parameter differs from the value specified in the null hypothesis. There are three types of alternate hypothesis. One is the left-tailed hypothesis, states that the parameter is less than the value from the null hypothesis. For example, it should have been H1, not H sub 0. H sub 1 is the alternate hypothesis, less equal to or colon mu less than 35. How do I know it is the alternate hypothesis H sub 1? The alternate hypothesis does not contain the equal to sign. Only the null hypothesis H sub 0 contains the equal to sign. Therefore, this is an alternate hypothesis. This is a left tailed. How do I know it is left tailed? The symbol indicating less than consists of two slanted lines meeting at an edge pointing to the right. So pointing to the left, the two slanted lines meet at an edge pointing to the left. Hence, this is a left tail test when it is less than. A right tail test hypothesis, a right tail hypothesis states that the parameter is greater than the value from the null hypothesis. For example, H sub again 1 colon mu greater than. Notice the symbol indicating greater than, two slanted lines meeting at an edge point to the right. It is a right tail test. A two-tailed hypothesis test states that the parameter is not equal to the value from the null hypothesis. And it is H sub 1, again, not 0. Again, why that is? Because null hypothesis always contains the equal to sign. So H sub 1 in the last one, when it's a two-tailed, is not equal to. Why it is a two-tailed? Because it's not equal to means it can be greater than or it can be less than. If it is greater than, it's right-tailed. If it is less than, it's left-tailed, since we do not know for sure whether it is greater than 35 or less than 35. The safe way to say that or state that is not equal to 35, and then it becomes a two-tailed test. State an appropriate null and alternate hypothesis. Boxes of certain kind of cereal are labeled as containing 20 ounces. An inspector thinks that the mean weight may be less than this. So the null hypothesis status quo H sub 0 colon mu equal to 20. Now the inspector thinks that the mean weight may be less than this. So the alternate hypothesis H sub 1 colon 2 dots is mu less than 20. Now the inspector has to collect evidence or collect sample data to support his or her hypothesis, alternate hypothesis, mu less than 20. Last year, the mean monthly rent for an apartment in a certain city was 800. A real estate agent believes that the mean rent is higher this way. So the null hypothesis H sub 0 colon mu equal to 800, always equal to sign in the null hypothesis. And the alternate hypothesis, real estate agent believes that the mean rent is higher. That means alternate H sub 1 colon mu greater than 800. Scores on a standardized test, have a mean of 70. Modifications are made to the test, and an educator believes that the mean may have changed. Notice the educator does not know whether it has gone up or gone down. So the null hypothesis status quo H sub 0 colon mu equal to 70. Since we do not know exactly the direction of the alternate hypothesis, we will state H1 alternate colon mu not equal to 70, and it's a two-tailed test. State an appropriate null and alternate hypothesis. Last year, the mean amount spent by customers at a certain restaurant was 35. The restaurant owner believes that the mean may be higher this year. So null hypothesis H sub 0 colon mu equal to 35. Restaurant owner believes that the mean may be higher. So H sub 1 colon mu greater than 35. Right tail test. In a recent year, the mean weight of newborn boys in a certain country was 6.6 pounds. A doctor wants to know whether the mean weight of newborn girl differs from this. So the null hypothesis H sub 0 colon mu equal to 6.6. This is the mu of the boys. And a doctor wants to know whether the mean weight of new girl differs from this. So differs does not say going up or down. So mu girls is not equal to 6.6 is the alternate hypothesis. Not equal to because we do not know whether it's greater than or less than. Certain model of a car can be ordered with either a large or small engine. The mean number of miles per gallon for the cars with small engine is 25.5. So the null hypothesis A sub 0 colon mu equal to 25.5. An automotive engineer thinks that the mean for cars with larger engines will be less than this. So alternate H sub 1 colon mu less than 25.5. Left tail test. The purpose of a hypothesis test is to determine how plausible the null hypothesis is. That how much is the null hypothesis, how much possible is the null hypothesis. The idea behind the hypothesis is similar to a criminal trial. At the beginning of a trial, the defendant is assumed to be innocent. So H sub 0 colon mu is equal to innocent. Okay, the defendant is innocent. Then evidence is presented. If the evidence strongly indicates that the defendant is guilty, not innocent, alternate H1 colon mu not equal to innocent, we abandon the assumption of isms. That means we reject the null hypothesis, which was H sub 0 colon mu equal to innocence. If there is enough evidence to support the alternate H1 colon mu not equal to innocent, then what are we going to? Because the evidence supports the alternate, then we will reject the null hypothesis and support the alternate that the defendant is not innocent. Okay. We abandon the assumption of innocence and conclude the defendant is guilty. In a hypothesis test, the null hypothesis is like the defendant in a criminal trial. At the start of a hypothesis test, we assume that the null hypothesis is true. Then we look at evidence which comes from data that have been collected. If the data strongly indicate that the null hypothesis is false, we abandon our assumption that it is true and believe the alternate hypothesis instead. This is referred to as rejecting the null hypothesis. So at the start of the test, on the left, we assume the null hypothesis, the stated value of the population parameter mu is equal to a certain value. Then we look at the evidence that has been collected from the sample. Okay, if the sample data provides enough evidence to support the alternate hypothesis, then of course, that's what they're saying. Then we look at the evidence which comes from the data that have been collected from the sample. If the data strongly indicate that the null hypothesis is false, or in other words, the data strongly supports the alternate hypothesis, then of course it is not supporting the null hypothesis. We abandon our assumption that the null hypothesis is true. Then we reject the null hypothesis and support the alternate. Okay. Reasoning used in hypothesis test. We reject the null hypothesis when the data provides strong evidence against it. That means the data from the sample provides enough evidence to support the alternate hypothesis. Then we'll reject the null hypothesis. The evidence comes in the form of a test statistic. What is a test statistic? It is a characteristic of the sample that we have gathered. When the difference between the test statistic and the value in the null hypothesis is sufficiently large, we reject null hypothesis. So the difference between the test statistic and the hypothesized value in the null hypothesis is very large, then we are going to reject the null hypothesis. Suppose an exam has been given to a large class and the instructor claims that the mean score on the exam is 80. Then the null hypothesis H sub 0 colon mu equal to 80. Now suppose that a sample of exam scores is selected and that the sample mean X bar is 78. Because 78 is fairly close to 80, it is plausible. That means it's possible that the null hypothesis is true. Why? The difference between the hypothesized value in the null hypothesis 80 and the sample mean 78, there's not much difference. Because 78 is fairly close to 80, it is plausible that the null hypothesis is true. Imagine, however, in the second scenario, the sample mean had been X bar equal to 50. Now look at the difference between the sample mean of 50, which is on the left of 80, and the hypothesized value of 80. The difference is too large. Because 50 is far from 80, it does not seem plausible that the population mean is actually 80. We would probably reject 80 in that case. Okay. This is because if the sample mean comes out 50, the sample is coming from the same population. If the hypothesized value, if we make an educated guess of the population mean as 80. How come the sample mean is coming out at 50? There is too much difference between the sample mean and the hypothesized value in the population mean, which is 80. Therefore, in most likely, the value we guessed in the null hypothesis is not true. Therefore, we are going to reject the null hypothesis in this case. Difference between test statistic and H0 value. We see that further the test statistic is from the value specified by H0, the less likely the difference is due to chance and the less plausible H0 becomes. The question then is how big should the difference be before we reject H0? Okay, how big is the difference between the sample evidence or sample mean and the hypothesized value in the population of the population mean in the null hypothesis? How big should the difference be? To answer this question, we need methods that enable us to calculate just how plausible H0 is. Hypothesis tests provide these methods taking into account such as the size of the sample and the amount of spread. Size of the sample is given by sample size n, and the amount of spread in the distribution is the standard deviation of the population. State conclusions of a hypothesis test to hypothesis test. If the null hypothesis is rejected, the conclusion of the hypothesis test is straightforward. We conclude that the alternate hypothesis H1 is true. This is the case when there is enough evidence to support the alternate, the sample data supports the alternate, therefore we are going to reject the null hypothesis and assume that H1 is true. If the null hypothesis is not rejected, okay, then we said that there is not enough evidence to conclude that the alternate hypothesis H1 is true. This is not saying that the null hypothesis is true. What we are saying is the null hypothesis might be true. So if there is not enough evidence to support the alternate hypothesis, then we do not reject the null hypothesis. This is different. We fail to reject the null hypothesis. This is different from saying that we support the alternate, okay? Because we do not know for sure whether the hypothesized value in the null hypothesis is true, okay? So if decision in that case, when there is not enough evidence to support the alternate, we fail to reject the null hypothesis and do not support the alternate hypothesis. Not enough evidence to believe H1 is true. H0 might be true. Examples stating conclusions. Boxes of cereals are labeled as containing 20 ounces. An inspector thinks that the mean weight may be less than this. So he performs a test of null hypothesis mu equal to 200 versus alternate H1 colon mu less than 20. State an appropriate conclusion if the inspector rejects H0. So rejects H0 means enough evidence is collected from the sample data to support the alternate. Because the null hypothesis is rejected, we conclude that the alternate hypothesis is true. We conclude that the mean weight of the cereal is less than 20 ounces. This is because we are supporting the alternate, because there is enough evidence from the sample data to support the alternate. Therefore, we are rejecting the null hypothesis. In the alternate hypothesis, mu should be less than 20, and the null hypothesis mean should be equal to 20, not 200. They cannot be two different values. In the null hypothesis, the value of the population parameter, in this case population mean, is equal to 20, and the alternate mu less than 20. State an appropriate conclusion if that does not reject H0. That means there is not enough evidence from the sample data to support the alternate hypothesis. Therefore, the decision is do not reject H0. Because the null hypothesis is not rejected, we do not have sufficient evidence to conclude the alternate hypothesis is true. In words, we state there is not enough evidence to conclude that the mean weight of cereal boxes is less than 20 ounces. Okay. Distinguish between type 1 and type 2 errors. When a hypothesis test is conducted and a decision is made, there is a possibility that it is a wrong decision. There are two ways in which a wrong decision may occur with hypothesis testing. If H0 is true, we might mistakenly reject it. So look at the first row under decision. Reject H0 is true. Reject H0. So first decision, reject H0, first row. Now look at the first column and the intersection of the first row and the first column. The decision is to reject H0, but H0 is true. We have made a wrong decision because in reality H0 is true and we should not have rejected H0, but we rejected H0. This is called a type 1 error. A type 1 error is made when we reject H0 even though H0 is true. Okay. And if we reject H0 and H0 is false, intersection of the first row and the second column of decision is fine, correct decision. Now let's look at the second row of decision. Fail to reject H0. Okay, fail to reject H0 is a decision and H0 is true. We made the correct decision. Now let's look at the intersection of the second row, fail to reject H0 in the second column, where the decision is H0 is false. So failing to reject H0 when H0 is actually false is type 2 error. Minimizing type 1 error. In general, a type 1 error is more serious than a type 2 error. This is because type 1 error results in a false conclusion. Remember, type 1 error is reject H0 when H0 is true. So we made a wrong decision and reached a false conclusion. Type 2 error, failing to reject H0 when H0 is false, we did not make any decision. Okay, failing to reject H0, we left H0 as the status quo. Okay, so there is no conclusion. Okay, ideally, we would like to minimize the probability of both errors, but unfortunately, with a fixed sample size, decreasing the probability of, say, type 1 error will increase the probability of type 2 error and vice versa. Decreasing the probability of type 2 error will increase the probability of type 1 error. Hypothesis tests are often designed so that the probability of type 1 error will be acceptably small, often 0.05 or 0.01. Okay, usually 0.05 or 0.01. And this is called the significance level of this test. So what does it mean? If your level of significance is 0.05, we are taking a 5% risk or chance that we will reject H0 when H0 is true. That is, we are taking a 5% chance of making a wrong decision. Examine types of error. The dean of a business school wants to determine whether the mean starting salary of graduates of her school is greater than 50,000. So the alternate is mu greater than 50,000. She will perform a hypothesis test with the following null and alternate hypothesis. Null is mu equal to 50,000, alternate mu greater than 50,000. Decide if a type 1 or type 2 error or a correct decision occurs in each case. The true mean is mu equal to 50,000 and the dean rejects H0. The dean should not have rejected H0. So reject H0 when H0 is true is a type 1 error. So she made a type 1 error. Okay. The true mean, second case, the true mean is mu equal to 55,000 and the dean rejects H0. In this case, the true mean is 55,000 and the dean has made the decision to reject H0. She has made the correct decision because the dean rejects H0. This is a correct decision. And case 3, the true mean is 55,000 and the dean does not reject H0. Fail to reject H0 when H0 is false, that's a type 2 error. Okay. Decide if a type 1 error, type 2 error, or a correct decision occurs in each case. A test is made of H0 mu equal to 100 versus alternate mu not equal to 100. Two-tailed test. The true value of mu is 150 and H0 is rejected. We made the correct decision, part A. Part B test is made of H0 colon mu equal to 18 versus alternate mu greater than 18. The true value is mu is 20 and 80 is not rejected. So in part B, we fail to reject 80 when 80 is false. So this is type 2 error. And in part C, test is made of H0 colon mu equal to 3 versus H1 mu less than 3. The true value of mean is mu is 3 and H0 is reject. So this is a case when we reject H0 even though H0 is true. This is type 1 error. So the first one is correct decision, second one type 2 error, and the third one type 1 error. Okay. So this is the end of this section. I'll stop here today. You can always write me a small note on if you like this video, please give me a thumbs up. I really appreciate that. If you like this video, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button. And also please click on the bell button because that will let you know every time I upload a new video, which is almost every day. And please make sure to visit me tomorrow when I will come back with another interesting situation. Thanks for watching. Take care. Have a nice day. See you later. Take care.